A3 is about rational functions in the graphs, and there's a lot of intricacies to these graphs of things that you need to look for. The first being a point of discontinuity. That's where the graph breaks. Okay, and so the graph of y equals x plus 3 times x plus 2 over x plus 2 has a removable discontinuity at x equals negative 2. That's because when you factor, you end up with, see, x plus 2 and x plus 2, they both cancel. That's still part of the graph, and that's what they call a hole. Okay, so whenever it cancels, it's a hole. The graph of y equals x plus 4 over x minus 2, notice they don't cancel, has a non-removable discontinuity at x equals 2. Why? Because remember, the denominator, which is x minus 2, cannot equal 0. And you solve x cannot equal, add 2, x cannot equal 2. That's why it has a point of non-removable discontinuity at x equals 2. So when we look at example 1, what are the domain and points of discontinuity of each rational function? Are the points removable or non-removable, and what are the x and y intercepts? So what we need to do first and foremost is I've got to go ahead and factor here. So x plus 3 on top, and I've got to go ahead and factor here. What's my AC number? 1 times 3 is 3. Again, only number of factors of 3 are 1 and 3. We're looking for a negative 4, so you could take a shortcut, x minus 3, x minus 1, as it factors. You know how to factor, you've done it before. Okay, so what are the points of discontinuity? So I'm going to take each denominator and set them equal to 0. X minus 3 equals 0. X minus 1 equals 0. So x cannot be 3. X cannot be 1. So my points of discontinuity are x equals 3 and 1. Because they don't cancel, they are both non-removable. Both non-removable, if I could talk. Okay, so that's what we have there. Now, the next part is what are my x and y intercepts? The x-intercept occurs where the numerator equals 0. So set x plus 3 equal to 0, x equals negative 3. That's my x-intercept right there. And the y-intercept is where x equals 0, just like always. So y-intercept is y equals, plug 0 in for x, 0 plus 3 over 0 minus 3 times 0 minus 1. Just this is calculator work. 0 plus 3 is 3. It gives me negative 3 times negative 1, which gives me 3 over 3, which gives me 1. So my y-intercept is y equals 1. Okay, what about here? Now, same thing. We need to factor the top. Well, my AC number is negative 4. 1 times negative 4 is negative 4. So 1 and 4, 2 and 2. We need negative 3, so positive 1 minus 4. So let's take our shortcut, and this is going to factor into x plus 1 times x minus 4 over x minus 4. So again, with points of discontinuity, what I want to do is take my denominator, x minus 4, and set it equal to 0. So at x equals 4 is a point of discontinuity. Now, is it removable or not removable? We'll see how y cancels up in here. That's what we call a hole, so that's what we call a removable point. So let's talk about x-intercepts. Remember, it's where the numerator equals 0. So we end up with, remember, these cancel, so my function is really y equals x plus 1. So that's the numerator. So what we want to do here is for x-intercept is take x plus 1 equal to 0 and solve x equals negative 1. There's my x-intercept. My y-intercept, remember, just plug 0 in for x into the original equation, and we can go from there. Y equals 0 squared minus 3 times 0 minus 4 all over 0 minus 4, which gives me negative 4 over negative 4, which gives me a y-intercept at 1 as well. Finding the asymptotes are the key to drawing your graphs here. So you're looking for either the vertical asymptotes or the horizontal asymptotes and how it goes from there. So again, this is kind of by definition what it is, and we'll talk more about finding it when I show you an example of the vertical asymptotes and the definition of the horizontal asymptotes. So get them down and we'll talk more about it as we go through the problems. So example 2, what are the vertical asymptotes of y equals x plus 1 over x minus 2 times x minus 3? Again, what this is dealing with is my kind of my points of discontinuity a little bit. So x minus 2, take your denominator, set them equal to 0. Get x equals 2, x equals 3. Because they don't cancel out, they're points of discontinuity because that's what your asymptotes are. So that right there are both your asymptotes. So if you're drawing this graph, those would be your vertical lines that create those asymptotes. If we look at example 3, what is the horizontal asymptote for the rational functions? I'll give you a couple examples here. And it's why I didn't want to get in the definition. But if I'm looking at this function, notice how this is to the first power and this is to the first power. So the powers are the same. When that's the case, when the power up top equals the power in the denominator, it's just the coefficients. Okay, so my horizontal asymptote is 2 over 1 or y equals 2 in this particular function. Well, if we look at b, notice how this is a 1 up here and here's a 2 down here, so it's bigger in the bottom. When it's bigger in the bottom, or bigger in denominator, your horizontal asymptote is always y equals 0. Okay, so again, now look here and see, it's bigger in the numerator. When it's bigger in the numerator, there's no horizontal asymptotes. Example 4, graph y equals x squared plus x minus 12 over x minus 4. Again, first step is to go ahead and factor the numerator. So what's my AC number here? 1 times negative 12 is negative 12. Factors of that, I'm looking for 1, so I know 3 and 4 is going to work. I need a positive 1, so it's negative 3 plus 4. Again, take your shortcut, and my new equation is y equals x minus 3 times x plus 4 all over x minus 4. Now let's start with the horizontal asymptote. Okay, horizontal, bigger power on top. I'm sorry, I'm a dummy. This should be x squared. Okay, so then we should factor the bottom. Again, different perfect squares, so x minus 2, x plus 2. So now we have even powers, so our horizontal asymptote is y equals coefficients of the top is 1, on the bottom it's 1, so my horizontal asymptote is y equals 1. So I'm going to come over here to my graph, y equals 1 is up here. I'm going to draw a dashed line through it. Let's do our vertical asymptotes. That's just the denominator equal to 0, correct? So x minus 2 equals 0, and x plus 2 equals 0. So x equals 2, x equals negative 2 are my vertical asymptotes. So let's go over to 2, draw the asymptotes. And negative 2, draw your other asymptote. And that helps you set up your graph. Let's find our x-intercepts first. Remember, that's where the numerator equals 0, so x minus 3 equals 0, and x plus 4 equals 0. So I get x-intercepts at x equals 3, and x-intercepts at x equals 4. Sorry, negative 4. So where's 3 at? Right there. Where's 4 at? Negative 4. 1, 2, 3, 4. Okay. Let's find our y-intercept. Okay. And where that is, where everything equals 0. So plug in 0 for everything. So it doesn't matter where you plug it in at. But you get 0 squared plus 0 minus 12 over 0 squared minus 4. That end up giving me negative 12 over negative 4, or a y-intercept of 3. So go up to 3, 1, 2, 3, put a dot. Now, again, it's kind of feeling this out, how this goes, and you should probably plot other points. But again, we're just looking for a sketch of the graph. And you can plot it in your calculator too as you want, but remember, you get really, really close to these asymptotes and never touch.